Hi everyone, this is Geeta working as Assistant Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchengodu. Today we have to discuss about the topic vector calculus. Introduction. Vector calculus is a branch of mathematics that deals with vector value, function and operation on vectors. It extends ordinary calculus to quantities that have both magnitude and direction. Vector calculus is widely used in engineering, physics, and applied sciences to describe and analyze physical phenomena such as force field, fluid flow, electric and magnetic fields, and motion. First, what is scalar? A quantity having only magnitude is called a scalar. Example, mass, temperature, time, speed. Vector. A quantity having both magnitude and direction is called vector. Example, displacement, velocity, acceleration and force. A vector is usually represented as A vector. The symbol arrow mark is represented as vector. A vector equal to AI vector plus BJ vector plus CK vector. Here I vector, J vector, K vector are unit vectors along the X, Y and Z axis. In X axis, we represented as I vector, in Y axis J vector and Z axis K vector. Vector function. A vector function assigns a vector to each value to a variable, usually time or position. Example, R of t vector equal to x of t I vector plus y of t j vector plus z of t k vector. That means x of t, y of t and z of t are functions of t. Next, differential vector calculus. Gradient del phi applied to a scalar function gives a vector del phi. Del is nothing but I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Here del phi is nothing but I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. Indicates direction of maximum increase. Next, divergence. Divergence is nothing but del dot A vector applied to a vector field. Gives a scalar del dot A vector. Dot product, taking the dot product from del and then A vector, we get divergence. Measures outflow or source strength of a vector field. Next, curl. Curl is nothing but del cross A vector. Applied to a vector field gives a vector del cross A vector. Measure rotation or circulation. Del cross A vector means we using the determinant of del and A vector. Next, solenoidal. If F vector is a vector such that del dot F vector equal to 0 at all points in a given region, then it is said to be a solenoidal vector in that region. Suppose any of the vector del dot F vector equal to 0 we getting means F vector is said to be solenoidal. Example, F vector, we taking the vector F vector equal to x plus 3y I vector plus y minus 2z j vector plus z minus 2z k vector. We have to prove this vector is solenoidal. The solenoidal condition is nothing but del dot F vector equal to 0. So first to calculate del dot F vector. Del is nothing but I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Dot F vector is nothing but given vector. Taking the dot product means multiple the coefficients of I vector plus coefficients of j vector plus coefficients of k vector. So we get dou by dou x of x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x minus 2z. Here differentiating partial with respect to x, we get 1. Next y is constant, we get 0. Next, the second term, differentiating partial with respect to y is variable, so we get 1, z is constant, 0. Next, differentiating partial with respect to z, so x is assumed to be constant, 0 minus 2, x z differentiating, we get 1. So 1 plus 1 minus 2, we get 0. So del dot F vector equal to 0, so the given vector is said to be solenoidal. Next, irrotational. If F vector is a vector such that del cross F vector equal to 0 at all points in a given region, then it is said to be irrotational vector in that region. If a vector is said to be irrotational means the condition for irrotational is del cross F vector equal to 0. Example, prove that F vector equal to y z I vector plus zx j vector plus x by k vector is irrotational. Is irrotational we have to prove means first to prove del cross F vector equal to 0. So first to find del cross F vector. Del cross F vector means taking the determinant in the first row I vector, j vector, k vector. In the second row, the del coefficients. Del is nothing but I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. And this value, the I, j, k vector coefficients are dou by dou x, dou by dou y and then dou by dou z. And F vector is nothing but this term. Here I coefficient is yz and then zx and xy. So taking the determinant, first I is assumed, corresponding row and then column omitted. Taking the cofactor matrix, we get dou by dou y of xy, we get x minus dou by dou z of zx is x. Minus j vector into corresponding row and then column omitted. Dou by dou x of xy is y and dou by dou z of yz is y. Plus k vector into corresponding row and then column omitted. Dou by dou x of zx is z minus dou by dou y of yz is z. X minus x 0, y minus y 0, z minus 0. So we get the final answer is 0. Del cross F vector equal to 0. So the given vector is irrotational. Next, angle between two surfaces. The angle between two surfaces at the point of intersection is defined as the angle between the normal at that point. Let the two surfaces be pi 1 of x comma y comma z equal to 0 and pi 2 of x comma y comma z equal to 0. We are assuming two surfaces pi 1 and pi 2. The angle is theta between the two surfaces is cos theta equal to del phi 1 dot del phi 2 divided by modulus of del phi 1 modulus of del phi 2. Example, find the angle between the surfaces x square minus y square minus z square equal to 11 and xy plus yz minus zx equal to 80 at 6, 4, 3. Here the two surfaces are given. Find the angle between these two surfaces. Let us assuming the first surfaces is pi 1. Pi 1 is x square minus y square minus z square. 11 is converting opposite side, we get minus 11. So first to find del phi 1. Del is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Phi is this term. This term is multiple inside. Here we get I vector dou by dou x of this term. Dou by dou x of the phi 1 function means x square differentiating, we get 2x. Y squared, z squared are all constant, so we get 0. Next, j vector dou by dou y. Dou by dou y means differentiating partially with respect to y. X and z are assumed to be constant, so we get minus 2y. Next, k vector dou by dou z. Z is partially with respect to z. Z is assumed to be variable. X and y are constant, so we get minus 2z. K vector. So del phi 1 now. Here the other point is given 6, 4, 3. X is 6 and y is 4, z is 3. Substituting in this vector, we get 12i vector minus ij vector minus 6k vector. Next to find modulus of del phi 1. Modulus of del phi 1 is nothing but square root of I coefficient square plus j coefficient square plus k coefficient square. So we get modulus of del phi 1 is square root of 12 squared is 144, minus 8 squared is 64, minus 6 squared is 36. Adding this we get root 244. Next pi 2, the second function is given by xy plus yz minus zx equal to 18. Equal to 18 is converting opposite side, we get minus 18. Next to find del phi 2, del is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Phi 2 is the given function. Substituting here, differentiating multiple inside this one and differentiating partially with respect to x by and z, we get the function as y minus z I vector plus x plus z j vector plus y minus x k vector. At the point is given 6, 4, 3. X is replaced by 6 and y is replaced by 4, z is replaced by 3. We get the vector as I vector minus 9j vector minus 2k vector. Next, to find modulus of del phi 2. Modulus of del phi 2 is nothing but square root of I coefficient is 1, 1 squared is 1 plus 9 squared is 81 plus 2 squared is 4. So we get root 86. Angle between the two surfaces is nothing but cos theta equal to del phi 1 dot del phi 2 divided by modulus of del phi 1 modulus of del phi 2. Already we have to calculating all the four values separately. Substituting in this formula, we get del phi 1 is 12i vector minus 8j vector minus 6k vector dot del phi 2 is I vector plus 9j vector minus 2k vector divided by modulus of del phi 1 is root 244. Modulus of del phi 2 is nothing but root 86. Next, dot product means multiple the coefficients of I vector, j vector and then k vector. I vector multiple we get 12 minus 72 plus 12. We get minus 48 by root 244 into root 86. We need theta. Cos is converting opposite side. We get cos inverse of minus 48 divided by root 244 into root 86. This is the angle between the two surfaces. Thank you.